It is time to conduct another scale audit on the diagnostics associated with a single CERT secure coding rule. So we'll go into the Jasper Diagnostics, and which rule shall we audit this time? I think we shall audit rule MEM 30-C. This is a priority 18 rule, the most severe that we have, and there's only 5 diagnostics. So we're going to filter out all the rules except for MEM 30. Only 5 rules to worry about. So we can see that MEM 30-C simply says do not access freed memory. We can look at the rule fairly quickly here to see the various ways freed memory can be accessed. It could be passed to free, it could be dereferenced. So I'll leave further details of the rule to other venues. And let's dive right in. So the first example we have here comes from Coverity, where it's claiming that JAS-TVP parser destroy is freeing TVP when it has already been freed. So I'll just verify that JAS-TVP parser destroy is indeed freeing the pointer. If we dive in there, we see that it's calling JAS free, and if we dive into JAS free, we can see that it's either memfree or it's defined here to simply be a wrapper to free. So we are indeed freeing the pointer, and Coverity claims we're freeing it twice. Why does it claim that? Coverity, in its usual fashion, provides some background analysis as to what's going on. I'm going to shorten this window a bit to make room for the code. So this analysis is actually some control flow analysis that Coverity is suggesting is plausible. In our function, starting with this function that contains the alleged vulnerability, it simply says, suppose that we take the false branch here, and we do not go to error, in which case we skip past that and move to the next branch of flow, and again we're taking the false branch and skipping the go to error. And this continues for a good bit until we reach line 573, the important one, where we see again JAS-TVP parser destroy, freeing the exact same pointer. In other words, there are 2 frees to this pointer here and here, but this intervening return statement suggests that the program either makes this call or makes this call, but not both. But Coverity suggests that there's another wrinkle, another possibility. Suppose we go to line 574 and decide that this if statement is true, takes a true branch. In that case, we go to error, and error is down here. And then we take the true branch down here, which we're going to do if TVP is not null. And in that case, we instead call TV parser destroy again. So Coverity has indeed found a case where TV parser destroy is being called twice on the same pointer. So this is definitely marked as true. So the first question is, are there any other tools that found this problem? We can figure this out by sorting by line number. And we can see that there are indeed 3 diagnostics on this item. Fortify discovered 2 and Coverity discovered 1. The 2 by Fortify are called use after free and double free. So this is in fact a double free vulnerability. So this is more precise than either the use after free that Coverity found or that Fortify found. But they are all correct. So these all get marked as true. And the remaining 2 diagnostics will mark as suspicious. Finally, since we discovered a fairly straightforward use after free vulnerability, this is an excellent case to write up a blurb to the client to convince them, especially their non-technical people, that we have found a serious vulnerability in their code. So here's the example blurb. It has the usual components of a blurb, all taken from the record of the diagnostic. So it contains things like the file name and line number. And we have the code sample. We sampled a much of the code to include both calls to Jazz TVP parser destroy. Following that, we have the rationale over why this vulnerability is plausible, followed by the CERT rule and the solution. We recommend the solution being to move the TV parser destroy code to, say, right before the return, which guarantees that even if some random error occurs, TV parser destroy would only be called once. This concludes our freed memory audit.